Hello. In this video of Office scripts, we're going to take a deeper look into the script itself. A script contains a set of instructions to automate tasks within Excel. Now, script runs from start to finish without requiring any user input. So that means it has all the information it needs to complete its automation task. And scripts do not interact with each other. A script can only invoke functions or instructions that are written right within inside it. You can start by recording or creating a blank script or edit an existing script. And there is a convenient inbuilt editor right within Excel. So there is no setup, no configuration, no libraries to import, and it's a very easy process to get started with. Now, to get sort of familiarized with the how the script is organized and to be able to begin to automate your tasks, there are some concepts that you need to know. Beginning with the TypeScript syntax. Scripts are written in TypeScript language, so basic understanding of the syntax as well as the static typings used within TypeScript are going to be important. Next, the Excel object models or the APIs. Now, these are the interfaces that allows you to interact with Excel itself. So it is important that you understand how they're organized, how to navigate around, how to discover APIs, and use them in your script. Then there is the structure of the script itself. So there is a predefined function called main, which is the entry point. So familiarity with that function and the argument that it receives, which is the workbook argument. And then in general, just how to go about organizing your script in a way that is easy to write and also for somebody else to read and continue to edit and run it. And then there is the actual environment where you put all of these things together. For instance, how do you record, how do you edit, how do you run, how do you examine results, and how do you share the script with others for them to use. So these are all some of the basic environment concepts that you will need to understand. So we're going to touch upon some of these in the next few topics. Beginning with the syntax. As I mentioned, the Office scripts is written in a TypeScript language, which is essentially JavaScript from a syntactical standpoint, but it also includes some things known as static typing. So types allows you to describe the objects, the variables. It allows you to describe the functions and what it accepts, what it returns. And overall, it helps with writing better scripts. So it helps you to avoid common mistakes that you can only discover later on during the runtime. So you can catch mistakes early. It also assists with code completion, which is a way to discover the type of objects or variables and then figure out which APIs to call. So all of these is driven by the static typing feature provided within the TypeScript language. And bottom line is it is there to help the author write a better quality scripts. And then there is the object model, the APIs offered by Office scripts to interact with Excel. And it is designed for end users who may not have a whole lot of coding background. So it is easy to get started with and to understand using the naming conventions and simple syntax used within the APIs to help you begin to interact with Excel. Now, the object model consists of a set of objects arranged in a hierarchical fashion, and each of the object consists of methods, which are sort of getters, setters, or actions, and easy to manage arrays of collections such as worksheets, tables. So essentially, the object model is structured to mimic what Excel looks like to the user, and helps you to easily discover and begin to use those methods. And then the editor provided within Excel app also helps with the auto completion, which is a way to do a dot notation and then discover what methods are offered within an object. So it's easy to navigate around. And then the error handling options are simple, and overall it offers a lot more features. Again, the emphasis is for users who may not have a whole lot of coding background. Now let's look at the main function that I referenced. So all of the functions, all of these scripts that you're going to see will contain this function called main. Now, main is the entry point to a script. And main function is required to be present in all of the scripts. Without the main function, it may still be syntactically a valid script, but there is no entry point for Office scripts to begin the execution. So it is important that you keep the main function as is. And also the very first argument that you will see is the workbook argument. So this represents the actual Excel file. And you'll see that the type of the argument is also provided right within the function argument list. And it is a way for TypeScript to help you understand that, hey, you're receiving a workbook argument to this main function of type Excel script.workbook. So Excel script is, think of it as just a family of all the types, and workbook is one of the object types within it. Now you can add additional arguments to the function, but it is important that you keep the workbook argument as is. All right. So the additional arguments are used in Power Automation scenarios, and I'm going to show a sample of that in the coming topics. And it helps, the additional arguments help receive data to the script, and also the main function can return results out of it. That is a way to send data out. But for simple scenarios where your automation runs right within the Excel application, you typically have only one argument, which is just the workbook argument. Now your code, your actual script logic, and your processing, all of that happens right within the main function itself, which in the body of the main function, as you can see here. All right, so again, keep the main function as is, and keep the first argument, positional argument, workbook as is. You can add additional arguments for more advanced scenarios, but for all of the scripts, the main function has to contain the workbook as the first argument. Now, and I mentioned the arguments that it can receive. So essentially think of the main function arguments and what it returns as a gateway to interact with the actual script. So here, this function, this script rather, receives a set of customer IDs and then does a lookup on a table. And then it for each of the customer ID that it can find a match on, it sends back the ID and the region in the form of an object array. So customer region that you see in the output type on the first line, it's just telling you that the main function returns an array of customer region object, which is defined all the way at the bottom as an interface. It contains ID of the customer that it received, one per customer, and then the region that if it could find a match. And the output itself is returned, as you can see towards the end, where I'm returning an output, and that is of the type customer region. So essentially, the point that I'm trying to make is that main function allows script to be connected to other parts of your organization. Now, Power Automation allows sending and receiving data to and from script. And if you're running the script right within Excel app, you will have to manage what comes in into the script yourself. But in the case of Power Automation, which is what it is designed for, you can feed in data. Like in the case here, I'm sending customer IDs in the form of a string, and that can be consumed within the script. And then the output goes out, and then the Power Automation can receive that and send to another flow action. So that's what the additional arguments are meant for, which is to receive input data into the scripts. Now the return, as I mentioned, is to send the data from the script to another flow that might be used as part of the Power Automation. Now, I mentioned the main function, but you can also organize your code by writing different functions so that you can write once and use it across many other parts of the same script. So you can use additional functions to organize your script. And the key thing to note is you can only call functions that are written within your own script. You cannot call into any function that's written outside of it. Its functions help you to organize your code in a manner that You don't have to repeat your logic over and over if you're doing the same processing at different times. So here, the main function calls in another function called add row at end, which receives the worksheet where the row needs to be added in the form of a sheet argument. The second argument, called data, receives the actual data to be added, and it does the processing and adds a row at the end of the worksheet. All right, so let's look at the object model. I mentioned that workbook is the top object that you get as part of the main function argument. Now, workbook sits at the top of the hierarchy, and I'm only showing few other objects that are part of the hierarchy, but there are many more. Here, the diagram is indicating that there are many worksheets that are part of workbook. There are many pivot tables. There are many comments. There is one active cell, and there's one application object. So each of these are objects within the workbook object. So all of these objects are defined in a hierarchical structure, beginning at the workbook level. Now, workbook, or rather any object, can contain properties and methods. So this is just plain TypeScript syntax, and the language allows you to have properties and methods. Properties can be scalar, like strings or numbers or booleans, or it can also be of type objects. So in this case, worksheets is a collection of worksheet objects sitting inside the workbook. An example of another object can also be something like a hyperlink object. So range object has a method called getHyperlink, which returns an hyperlink object, which in itself can contain other properties like address and text. Now, scalar property tends to be of simple types like strings and numbers, and usually it represents something such as like an address of a hyperlink, or a name of a worksheet, or a position of a worksheet in the form of a number. For instance, you can also have something like, hey, does this table have a header or not, which tends to be a Boolean property. Now, methods mainly perform three types of things. One is the getters, which means it gets some property or another object. So here examples are getName, getActiveCell, which returns a range object, get me a table, get a list of worksheets that returns a collection of worksheet objects or an array of worksheet objects. And then there are setters. So these actually sets some scalar property, like in set name or set position. And then there are methods that are of type actions, which performs some action on the workbook, such as deletion of an object, or calculate, or to resize a chart, for instance, or clear a range, or position a chart to a certain cell. So these are all different types of methods that you can get as part of an object. And there is also another special type of a getter method, which is getCollection. So a collection could be something like get tables, get comments, and the different thing about this is that it returns not one object, but it returns an array of other objects. So in order to get all the worksheets of a workbook, you call get worksheets, and returns a list of all the worksheets. All right, now let's look at some of the concepts that we just talked about in practice. So here I'm in Excel for Online, and I see the Automate tab, which is the place where all the Office scripts features are surfaced. And it comes with the record actions, which is a feature through which you can record your actions that converts into a script, using which you can get a base script to start with. Or you can access the All Scripts task pane that shows list of all the scripts that I currently have. And it also has scripts that are shared with this workbook, which is a way to pin scripts to a workbook, and other samples to help you get started out with. Now, as I mentioned before, there are three ways to start out. You could record and get a script, or you could edit existing one, or you can simply create a new script, which is what I'm going to do right now. Now, once you have the script, the familiar main function is going to be present. So you get that out of the box, and you'll see that it has the workbook parameter. So workbook is just the name of a variable. It is of type Excel script workbook. Now, Excel script is the top level namespace under which all of the APIs or the types of the APIs that we offer is going to be grouped under. So workbook is one such, and you also find other things like worksheets and range and so on, as we'll see further down. Now, the cool thing about the editor is using the variable name and the dot notation, you get to discover all the APIs that are available. So this is a nice handy way to figure out what APIs that you're looking after. And it also filters based on the typing you do. So let's say I'm interested in knowing the name of the workbook. So I can just simply type name, and then it shortlists all the APIs that contains the word name. And it also searches in the middle of the name. It just doesn't have to be at the beginning. So so here's a good example of demonstrating the types of methods that are available, beginning with the getter API. So the workbook get name returns a string which contains the name of the workbook, and you know that by just simply hovering over the API name, and you know that this is a method, and it is returning a value of type string. So this is a what is known as a scalar variable, which means it's just of type string, basic type. Now, there are other more interesting APIs that you can also find. So let's say I want to read the data of the current cell. So I can do that by using another type of a getter method which returns an actual object. So I can say cell, give me, I'll just look for word cell. So that is the get active cell. And remember to open and close parentheses for method names, because it is essential that you execute the method. Otherwise, it will simply assign that function, and it is not useful that way. So now I execute the method, and the value that I get back is assigned to this constant variable called cell. Now, constant is a TypeScript keyword that just simply says that, hey, I'm going to assign this to once, to this variable named cell once, and I'm not going to reassign it. If you wish to reassign it to another object later on, you could use the let keyword. Right, so now that I have that, I can now begin to explore the cell object furthermore to see what else does that offer. So I'm interested in getting the, let's say, the text value that is displayed here. I can use the dot notation again and simply just type in text. I know that it has the text, get text. So there are usually for range API, you find the singular as well as the multi-cell APIs, and so in this case I'm only looking at the current cell, so I'll get the singular version of that. And then you can also display it, and when I run this code, you run the code by simply clicking on the run button, and if there is anything to display, it displays at the bottom in the output section. So here you can see that it is displaying the current highlighted cell. I can move to another cell and then run the same code again, and it displays the new cell value. So what you saw are two different type of getter APIs, one that returns a scalar value, another one that returns an object, in this case a cell, which is really of type Excel script range, and then using which you can get access the methods that the cell itself offers. Now I could have done this all in a single line using what is known as a dot notation. So for instance, I could do get cell and dot get text. And it is useful to do this when you know that the value that you're fetching out of the API that precedes the dot, in this case this is active cell, is going to be present. There are cases where the dot notation may not work really well, so I'll show that to you in a second. So using the dot notation, you can go down as many levels as possible, as long as the dot notation after that makes sense to you. For instance, here, because getText returns the string, that is really the leaf node that I'm looking for. But if I had, say, get off of the cell, I could do something else, like let's say get column, and then I could do dot further down and go further down like that. So in this case, all I'm looking for is just the text value, so I'm gonna stop at that. Now, the methods that you've seen so far with open and close parentheses, none of these accepts any arguments, but some APIs, some method calls do require arguments. Right. So let's say now I want to display the position of a sheet and display the number or the position where it occurs in the workbook. So to do that, I first need to get the actual worksheet object itself and then display its position. So I can do that by first getting the position using the dot notation that I was talking about. So workbook, so let's say worksheet, and the get worksheet requires an argument. And when you do open parenthesis and keep your cursor in the middle, it is telling you that, hey, it requires a key of the type string. So let's say I'm looking for sheet 4, and then I can get the position and simply display that. So when I run this code, it displays the position that I'm in. So this is 0 index. It's saying that I'm in position, the first position. This is 0th position. So that works out fine. So as you can see, the dot notation was convenient. But there are cases where, especially when you supply an argument, and the resulting value may not return an actual object that you're anticipating. So in this case, let's say I do sheet 3. So there is no sheet 3. And when I try to get this and run this, it says that, hey, there is no such thing as get position of undefined on line 4. So the problem here is that I was a little bit ambitious in trying to use the dot notation in cases where I know that the resulting value coming out of the get worksheet API may or may not be an actual worksheet. Whereas in line 3, the get active cell, so I know there is always an active cell in a workbook, so it is safe to use the dot notation and carry on. But in this case, I will have to use a little bit more logic to handle this correctly. So to do that, first you need to know what undefined is. So undefined is a native TypeScript type, and it essentially means that a variable is not assigned with an actual object or an actual value. So in this case, the get worksheet could not return any meaningful result, so it assigned by default undefined. So the result of the get worksheet in this case, so let's call it sheet, and so the sheet now contains undefined. So I first want to check before I go further, saying, hey, if sheet, so that means if sheet actually has any value, and then I can go and say, okay, get me the sheet position, else get position. And else I can handle the condition. So let's say I just want to say, hey, this sheet is not present. So this is one way of handling the conditions, where you know that the API may or may not result in something that you're expecting. So this sheet 3 doesn't exist, so sheet 4 I should get the value of 1 as expected. So what I showcased so far is the ability to use the methods off of an object, get scalar properties, things like name and position, and also use the same getter methods to get another object, and using which you can continue to chain, but do take precaution on APIs that accepts arguments, because those APIs may not return the result that you're anticipating. So in this case, getWorksheet. Some APIs requires arguments, and arguments may be required or optional. And when you hover over any method, you will see that it'll display all the things that it needs from argument standpoint, like all the essential argument it needs. In some cases, you don't need an argument. All right, so we looked at certain types of getter methods. So there is one other sort of special type of getter method. Those don't return a scalar or an object, but rather it returns an array of objects or a collection of objects. And those methods usually end with the plural notation. So in this case, let's say I want to get all the worksheets. So I could say sheets from the workbook, get worksheets. So the difference here is that it's not returning a single sheet, but we saw active worksheet earlier, but this is the worksheets collection. And when I hover over, you'll see the notation of the open close parenthesis. That means that it is returning an array of type Excel script worksheet object. So I can also find out by hovering over the sheets variable. It says that, hey, this is of type worksheet collection. Now, once I have the collection, if I wish to get to the individual elements of it, so each individual element of this array is an individual object. So in this case, worksheet. So let's say I want to display all the names of the worksheets that are associated here. So I could simply collect let's say sheet names, and so let's say I'll assign a blank array, and I'm going to simply iterate over using a for loop. So for loop is something that JavaScript provides to iterate over the collections. So let sheet of sheets. So this is one of the many different ways you could iterate over a collection. And then I'm gonna push the actual sheet name one at a time using the get name method. And simply at the end of this loop, if I display the sheet names, I should see all the sheet names in this workbook. So the resulting object is still an array, because all I'm doing is pushing one item at a time by iterating over individual elements. And the collections or arrays are quite powerful because you can do other sorts of things with it. So let's say I want to order this in ascending or descending order. So I can do that by once that I have all the sheet names collected, I can order the sheet names, and this is processing that's happening on your TypeScript side, on your script side. So I can now sort. So sort is again a method, native array method that the TypeScript offers. So once I sort this, I can do a for each, so which is again a native a TypeScript method that accepts a callback function, which means whatever you supply in here, it's going to perform that once per instance of that array. So here I can get the sheet and the index. So this is supplied to me as part of the for each function. And so once I have the sheet name, I can go back and get the sheet name, get the worksheet. So remember, get worksheet requires a parameter of sheet name. So here, so let me call this sheet name. And then I could do the set position. So set position takes in an index and a number. So I can do the index. So where did the index come from? So the for each accepts a function, and that function automatically gets the instance of the array that it is iterating over, and then also the index that it is on. And the argument was supplied by TypeScript, so I don't have to worry about it. All I need to worry about it is how do I process that within the function. So when I run this, it is going to order, as you can see. Now, let's say I want to reverse the order, so I could sort it and then reverse it, and reverse is again a JavaScript or a TypeScript function. And when I run this, it will reverse the order in which it is sorting. So this is kind of quite powerful in a way that you can use collections, and it is also quite easy to manage that. Now, the one other concept that I talked about was arranging your code in a way that makes it easy to reuse. So let's suppose the cool sorting functionality that we saw here is going to be called multiple times during your script. So instead of repeating these lines over and over, I can extract the logic into a separate function. So I'm going to call that function sort sheets. And then it will accept an argument of type workbook, and I'll say Excel script, which is the top level namespace. And then let's say I want to figure out what is the order in which I want to sort. So I'll accept another parameter called reverse, which is of type Boolean. And it doesn't return anything, it simply sorts the function, sorts the worksheet. So I can simply copy all of the code here into this function. I need to account for the fact that the reverse could be true or false. So so let me collect that. So I'll create a variable, and then if the reverse is true, I will assign sorted sheet names to the one with the reverse, and if not, I will simply assign it without the reverse, and then I can keep the rest of the code as is by simply using the new variable that I created. So now that I've defined this function, I can call this function from many other places. So to call, I will need to invoke it. So sort sheets. So remember, anytime you call a method or a function, you need to execute by open close parenthesis. And TypeScript auto-completion is saying is that it requires two arguments, of one a workbook, another one of type whether should I reverse or not. So let's say right now I'll say no. So when I run this code, it is going to simply call the sort sheets. It is not returning anything, it's directly acting on the workbook, and it sorted in the order. So let's say I want to reverse the order, I can simply change the argument and have it sort in the ascending order. Now the arguments, so these are the two arguments that I provided. Now the reverse is both are required arguments, which means the function cannot operate unless both arguments are provided. Now if I do not supply one of the argument, TypeScript will complain that, hey, look, it is expecting two arguments, but you're only supplying one. Now, let's say by default, I only want to sort this in the ascending order, and only in cases where I want to sort in descending order, I want to provide the variable. So in that case, I can make the reverse as an optional argument. So by simply adding a question mark, I made that into an optional argument. So now I don't really need to supply. So in this case, if I run this, it'll sort in the ascending order. Right. So this is one way of controlling what you want to pass as required and what that you don't want to pass as required. So this was a function that that you wrote within the script, but the concept of arguments, optional or required, is a generic concept that you will see even on for Excel APIs. Now let's look at two other types of methods that I've talked about. So I'm going to comment this out. So I introduced you to two types of methods. One is the getter method that returns an object or like a variable, like a name at a position, and then another type of a getter method that returns a collection. Now let's look at another method, another type of method that sets the value, which these are called setter methods. So here I want to change the active cell value. So I will simply do that by getting workbook, get active cell, and I'm going to look for set value. So it accepts value. I'm going to change that to say new sample data. And I'm going to run this code. So it changed the value to new sample data. So this is the setters allow you to change some content within Excel, whether it's values of a range or a name of a chart or position of a sheet. So these are all sort of setter values, setter methods. And then there are other type of methods that does some unique action. So in this case, let's say I want to clear the range. So here, so let's say I want to, it has all sorts of formatting. Now I can take the active cell, and instead of setting its value, let's say I want to clear it. Now clear accepts an optional parameter called apply to, and it is of type enum or enumeration. And enumerations are a way to ensure that you don't supply invalid arguments. So clear apply to, and then dot. Seems like there are 3 different options, or 4, or rather 5 different options. The first one removes all, let's say, contents and formats. So let's say I want to only clear content. So I can run this API, and it'll only clear the content and leave the formatting as is. And I can come back and change this to formats. It'll now change the format as well. So this is not a setter method, but it is a type of a method that makes some sort of update on your workbook. The other types of such methods are things like deleting a table or a worksheet. So they actually cause some write action on your workbook. All right, so the last thing I'm going to talk about is the importance of typing. So throughout these samples, you've seen typings show up in many different places, whether it's in defining argument in the function argument list, define the type in the argument list in the main, or the function that you wrote yourself. The other place where it'll show up is when you define the name. When you define a variable, you can define a type. So let's say here I want to call this sort sheets. Before I call that, I'm going to comment this code. So let's say you want to supply whether to sort it in reverse or not. So let's say that may come from another location. So here in this case, I'll say sort order, and I can use the sort order in here. And if I do this without defining the type, this will complain that, hey, look, you're defining it of a variable using a variable of type any. So any is a type where if TypeScript is unable to infer the type, it is going to complain that, hey, look, I don't know what type you are using, so I cannot function correctly. So it is important that anytime you declare a variable, you assign it immediately, or at the minimum declare its variable name. Sorry, its type. So here, using this, I can, somewhere else in the code, the variable can be assign an actual value and that meets the criteria defined here. If I define something else, TypeScript is going to complain that you're defining something else. So it is essential that when you define a variable, that you assign the value immediately. If you are unable to assign value, as in the case here, I'm just defining a variable, but you have to also define the type. So if you do not do it, the result can be unpredictable. In some cases, it'll simply throw an error. So here I'm going to fix this, and now TypeScript is not going to complain. The one other error that you might see is the we don't allow explicit-any type, because when you define a type, let's say some variable of type any, so you will immediately get an error that says that, if you see the red squiggly line, it says explicit-any is not allowed. And TypeScript works best when you define the type of variables or the arguments. In this case, OfficeScript simply doesn't know how to handle this, in what context to handle this. So make sure that you don't define of type any. In fact, the script will not run if you do that. And the second thing is, in the functions and when you define your variables, make sure you have the type definition declared. All right, so I think that covers most of the important topics that we discussed early on. There may be several other concepts that will become familiar with you as you progress further down the line. Do check out the links in the description that offers many other samples using which you can kind of continually grow your skills. If you have any questions, wish to see different type of samples, please leave a comment. Thanks for watching.